This video is about solving problems involving a ramp or inclined plane.
So why is this a 2D forces problem?
So this is a two-dimensional forces
problem
because we have an angle here.
Angle is
So some of the forces will be in
so the two forces here,
and some of them will
tension 1
just
and tension 2.
2. They're both at an angle. So each of these forces.
So an
is
object
in
of
two
9.3
dimensions.
kilograms rests on an inclined plane.
So these forces
The
are
angle
used
of the
to pull a
ramp
cart
that's
is
stuck in the
23
mud.
degrees. The angle is
Find the
15
magnitude
degrees.
of the friction
tension in
force.
each rope is 300.
So notice the
So we
object
know
is
the
at
tension
rest.
already
It's resting
in
on the
two
inclined
ropes.
plane.
So we know
they
some of
tell
the
us
forces
magnitude of
are
the friction
equal and
force is
opposite
515
because there's no
newtons.
acceleration.
Remember,
the
the
object
friction
is at
force
rest.
always opposes the motion.
So what we
that will be
do is
opposite
start
to
with
the
a
way
free
that
body
the car
diagram,
cart.
and
So we
the
can
mass of the
draw
cart is 173 kilograms.
something like this.
So always find the net force when you're
and
doing
the angle is
question.
23
It won't ask you
degrees.
usually to find the net force.
So there's our angle
always find the
of
net
23
force.
degrees
In
from the
two-dimensional
horizontal.
questions. You have to find the net force in the x and y directions.
So we measure up
So
to
usually
horizontal
what happens
23
is there's
degrees
nothing really
angle of the
happening.
ramp.
There's no motion,
And the
in
object
one
is
of the
resting on
directions.
the ramp.
So in
we
this
can draw
case, there's
a
going to
free
be
body
no motion
diagram
in the
for the
y
object.
direction, and we can find that by
ramp.
using the
And then
finding the net force.
think
in
about the
y
forces
direction.
that are acting on this object.
So if you remember,
while
the
it's
net
at
force
rest.
is the sum of all the forces in the y direction.
So there's always the weight.
So if you look at the picture here, we have
Fg,
that's supposed to be
which is
line.
always
We can make
straight
two
down.
triangles here, and
So no matter what the
we have a
orientation
y
of the
component
object,
for
the weight is
F1,
always
and we have a y component
directly
for
down.
F2, and we also have the x component.
so there's our weight. We also have a normal force
For now, I'm
because
just going to write here.
this object is at rest
The x components
on a surface.
are kind of
So anytime
overlapping
there's a
here.
surface,
On the
we have a
bottom of the
normal
triangle,
force.
there's
And if you remember
one
from the
for
notes, the normal force
first
is
force,
always
and then the other one
perpendicular
is here. So it's
or
nice to
90
draw these as
degrees,
separate
to
triangles.
the surface.
So I'll just do that.
So our
down
normal
here.
force
So
is here. So we have the weight, we have the
tension
normal force.
the first tension force
We
here.
also have friction
Triangles
because
look
we're asked to
something like
find
this.
the magnitude of the friction force.
We have the y component. We have
So
the angle
we
here.
have to decide
We
now
have our
which
x
way
component.
do we draw
So
the
it's the
friction.
same picture, but upside down.
So if you think
for
about the situation,
the other tension,
if the object is at rest on the
here's
ramp,
our x component. So in the y
there's no,
direction, we only
it's not going to
have
roll down the
two
ramp
y
or
components.
move up the ramp.
These
So
forces.
it's balanced by
So F1y
some opposing force.
plus F2y.
So if you think about
Remember,
if there
the net
was no
force is
friction
the
here,
sum.
the object would
Add
roll
them
down
all
the
together.
ramp or slide down the
And
ramp.
if you remember, how do we find the
So
y
that means that
components?
friction is
of a force,
opposing the motion or
The y
potential
component
motion
is
of
equal
this
to the force
object.
times
So we
the
can draw
sine
the
of
friction
angle. So
up
in this
the-
case, our y component
directed
will
up
be
the ramp. So opposite the direction that the
320
object
newtons.
would
That's the
move
force
if there was no friction.
times sine of the angle, which is
So
50
we need-
degrees.
We have an angle here.
So
This
if you
angle
calculate
given in
this,
the question, 23 degrees, is also going to be the angle
so
inside of
82.8
here.
roughly.
So our weight is going to be a two-dimensional.
That would be
It's
newtons.
going to have a y component and an x component.
So it's going to be the same number for the
So
other y component.
the y component
What's different here is
is
we're below the
straight-
above the x-axis
straight down
here.
like this.
So
You can notice it's
F1y is
parallel
positive,
to the normal force.
and F2y
This
is
would
below
be
the x-axis. which is
FGY,
right here.
the y
So
component of the
F2y
weight.
is negative.
And remember, the
So
only
we're gonna
reason
get the same number.
weight is two-dimensional is because there's an
But
angle
one is
here.
negative, one is positive.
So we can make our right triangle like we always do.
So we're going to get 0 here.
So we have
So you
the
could say 82.8
y component
newtons plus
FGY,
negative
and then we have the x
82.8
component
newtons
down here.
that equals 0.
Just to maybe
So there's the net force in the y direction here is 0. There's no
clean this up a bit.
acceleration in the y direction.
I'll just move the
no motion in the
FG
y
over
direction.
to the other side here.
So that's not very helpful.
So the
we
actual
need to
weight
find the acceleration
vector
here.
is
So we're looking
FG.
for somewhere where the net force is not 0. If you remember,
straight down.
if the net force
And
is
then
not 0,
we have
then
an x
the
and a
net
y
force
component
is
for the
m
weight.
times
So
a.
we need to find the magnitude of the friction
So
force
let's see
here. Here's our
when
friction
we do
force.
the net
It's
force
going
in
up
the
the
y
ramp.
direction.
So
Sorry, the
if
x
this
direction.
object is at rest, that means, if you
In
remember,
the
that
x
means
direction,
net
we have
force
the two
is
x
0.
components of the tension. We also have our friction
Net
force.
equals 0 here.
So this blue arrow here.
Because the object is
remember
at
that
rest,
friction is
so
always
in the
opposite
x
to the
direction, the
motion.
net force
It
is
always
0.
opposes the motion.
Moving along the ramp.
So in the x direction,
and in
we
the
have
y
friction
direction
force
as well,
right along the x-axis,
the net
and
force
then we
is
do
0.
have the two x
Because the
components
object is at
of the
rest.
force.
Anytime the object is
of
at
the
rest, the
forces.
net force is equal to
So
0.
F1x, F2x. And so how are we going to
let's see
find
if
the
this equals
friction
0 or
force
not.
here? If we do the net force in the
Well,
x
probably
direction,
not, because we're looking for acceleration, but let's
we
see.
add up all the forces that are in the x direction. So this is our,
So the friction force,
we know the friction force. Surface of the ramp
515
is our
newtons.
x.
That would be negative,
Our x-axis,
because
and then
to the left here is
the
negative. We're also to the
normal
left
force
of the
and
y-axis.
the y component of the weight,
and
are
the
on
x components are going
y-axis.
to be positive.
So
Both of
looking
them to
along the
right
x-axis,
of
we have the
y-axis.
friction force, and
So the
then
friction
down here
force
we
is
also
negative
have the x
515
component of the
newtons.
weight. And so
And then our x components,
when we write the net force, we have friction force plus the x component of the
force
weight.
is the force times cosine
And these
of
are
the angle.
going to be equal and opposite. The net
So
force is 0. We
that
know
would be
this because
320
the object is at
newtons
rest.
times cosine.
So we can write
15
0 for the net
degrees.
force equals the friction force
And we're going to have
plus
the same thing again
the
for
y component of the weight. And if you remember
the
from
x component of force
2D
too.
vectors, if you're finding the x component
So
of the
320
force,
newtons again,
you just take the
times
force
cosine 50.
and multiply by cosine theta
See
normally.
what this works out to. So
In
our
this
first,
case, if you look at this triangle,
the friction force is
if you remember I said ramps are a little different.
and then we're going to add
If you
these
look at the
two
triangle,
and
the
see
x
what we
component is opposite the angle. So that would be sine. So only when you're doing ramps,
so
the
we
x
got roughly
component
309
is f
newtons per
sine of the
so
angle.
320 times cosine
So,
15 is
In other
roughly
words, that's going to
309.
be fg
So if you notice,
times
this is,
sine
now like adding
of the
integers
angle,
together, right? We
which
have
is 23
negative,
degrees.
two positives. So we can add these all together.
So very
to get
important.
our net
You know,
force in
usually
the x
finding the x
direction.
component is always cosine, the y component is sine.
And
if
we
we're
don't
gonna
get
draw
zero
a
when
triangle
we do
like
the net
this,
force here,
and if
that
we want to
means we
use the
have
same angle
acceleration.
that's given in the question,
So what is
we
our
have
result
to
here for the net
use
force?
sine for finding
So
the x
309
component.
plus
So we're looking
309
for the friction force, which
minus
is right here in our equation, and so we can just rearrange this. So the friction force,
So our
we're going
net
to
force
subtract this piece, is
is
equal
103
to
newtons, which is not
minus
zero,
fg
right? Obviously,
times sine 23.
if the net force is not zero, then it's equal
And
to
if you remember, FG
m times a.
Weight is
If we
m
want the
times
acceleration, all we have to
221
do now is divide by the
meters per
mass.
second squared. So
just
minus
do that over
fg would be
here.
minus mg
Remember, acceleration is the net
times
force
sine
divided by the mass.
23.
So here,
So our mass
net force is 103
is
newtons
9.3 kilograms.
divided by the mass of
G
170
is going to be negative 9.81
kilograms.
meters per second squared.
So
So
our acceleration is
I encourage you to
roughly
try this calculation on your
0.59
own.
or even
I'll do it right
0.6
now. So 9.3
meters per
kilograms
second.
times 9.81.
So for the 2D
So this is
forces
going to be
problem,
positive.
don't forget
because we
you
have a
always
negative
have to
number
find
here
the net force
in front of the
in
mass,
the
and
x
g is also
direction and the
negative.
y direction
And then
separately.
we're going to multiply by
There's going to be
sine
acceleration
23,
usually in one direction and not the other.
and I get
So write the net force in the x
35.6
direction, write the net
for
force in
some
the y
other
direction,
digits. So maybe
and see what you get for the net force.
35.6
If it's zero, then look for
newtons for
an
the
acceleration
friction
in the
force.
x
That would be
direction.
positive. We got a
It is.
positive answer, which tells us
And
that
don't
it's
forget also how we
the
find the
direction
x and
is
y
up
components.
the ramp.
Of
Down the ramp
forces.
would
So
be
the y
negative.
component is the force times sine theta.
Um,
The x component is the force times cosine theta.
If
So
you
try
think
this
about
problem on your
significant
own.
digits,
Make sure that
last
you're
thing
able
I
to
wanted
do it
to
on
say,
your own. You'll see
you look at the number of
question
digits in the
exam similar to
question,
this.
right? 23.
And
So there's two digits there.
always let you
We have
start
three
your own
digits here.
question.
So the least number is 2. So we're going to answer to 2 digits, which would be, you could round this to 36 newtons. 35.6 rounded up to 36 newtons. So the friction force is 36 newtons. And that would be equal and opposite to the x component of the weight. So the x component of the weight would be negative 36 newtons. So these two forces, the x component of the weight and the friction force on a ramp, if the object is at rest, these forces are going to be equal and opposite. So if you know if you can find the x component of the weight, then you know the friction force.